Okay, good. Recording, yeah. Okay. This comment, when you do the homework, you just advise, just if you come in, everybody did reasonably well. Some people did very well on this brief quiz. It turned out not to be so brief. Everybody did okay on it. Had to give people a couple of hints. Okay. Now, you really need to try to do the homework in such a way that you don't need hints and don't make mistakes on problems that are very similar to the ones that you solve. Okay. And I'm not, criticizing anybody or getting after anybody on this, but just a practice that could really help is, first place, look at other materials as little as possible when you do the problems. Okay. I mean, you'll go ahead, if there's a video with the thing, because there usually are videos with most of types of problems. Yeah, get what you can out of the video, even take some notes on the video, and then try putting all that away and doing the problem without looking. First time, you're probably not going to be able to do that, depending on how quickly you pick it up and how well you understood what you wrote down as notes. Okay. But the first problem that doesn't have a video, you should try to do that without looking at anything, because you only learn by bringing it out of your memory. Okay. One step in learning is, go by the video, go by the examples. Okay. Try to figure out where the principles are and try to make yourself a note on what those principles are. If you have a note on the basic things you have to understand to do these problems, there aren't that many of them. Aren't that many basic things you've got to understand. You can try to boil it down to what you really need to know. So when you review for a test or exam, you've got that condensed knowledge. Now, you might not understand every note you made. You got, being able to make good, concise notes is an art that takes years to perfect. Okay. So if you can only get halfway to perfection this year, that's fine with me. Seriously, you might not understand when you're reviewing, but you'll have some idea. So then you go look a little deeper and you clarify your notes. Okay. And you practice. Okay. You learn by practicing on problems. I'm giving you enough problems that you should get enough practice, but you can always go back and use the assignment for practice. It's always open for practice, unless I screwed up when I did it. And if you find that it isn't open for practice, email me and I'll fix that. Okay. It's easy to fix, but I've kind of proofread all 50 assignments or whatever it is. I'm pretty sure most of them, I haven't been able to find any cases where they are, but I'm sure there are some where it might not be open for practice. Okay. In practice, if you want a million practice problems, just let me know. I can generate a million. Might have to write code for the problems and run it, but in many cases, I've already done that. Okay. And if you don't want less than a million, okay, just ask for 1,000. That might be enough. That satisfy everybody? 1,000. Okay. Well, okay. Now let's get to this. So on this second problem, let's do the second problem first. Okay. So you got 5 times 2 to the x equals 50. Now you know what the rules are. Matter of fact, I wrote them down in the support class. Okay, I always use B for the base. I don't always remember whether he's A here or here, but you understand the pattern. The pattern is correct. Okay. This is equivalent to this. If you look at this, you're going to see that you've got a 2 to the x, and the x. Well, the key is the thing you're trying to solve for is up here in an exponent, so you're going to have to use this. Okay. And it turns out you can't use this, not because you don't know how, but because some equations could have expressions where this doesn't work. Okay. then you're not gonna be able to solve the problem. And I'm probably not gonna be able to solve it either. There's probably no way to solve it, okay? Okay, well, now, again, what we see is your variables here. That means it's in an exponent. The only thing you have in this rule that has an exponent is this. So you're gonna have to rely on this, okay? Now, you know that, you've done it by habit. Most people, you know, with maybe a little prompting, remember how to do that, okay? So we have to apply that here, but you see, we got this 5 in front of 2 to the x, and there's nothing in front of b to the a. So we can't have that 5 there. So naturally, we do what everybody did, I think. You divide both sides by 5, and you get 2 to the x equals 10. And then you translate this into log base 2 of 10 equals x. So that x equals log of 10 divided by log of 2. And that's approximately, I'm going to make a guess, 3 point. Okay. And you can punch it out in your calculator, have a good laugh at my expense. It's way off, but I don't think that far off. Okay. Well, that's a pretty standard procedure that I can kind of tell that most people are used to, right? Because what so many people did on this first problem was 4 to the 3x minus 2 equals 100. And then you try to do this, and then 4 divided by 4 is 1, so you got 3x minus 2 equals 25. Easy to solve, right? What's the flaw in that? The flaw is if you divide this 4 into this 4, you violated the order of operations. Okay? Operation says exponent first, and there's an exponent. Make sense? Now, I could tell if you did that, though, that you were thinking this, okay? Because you know to get rid of that number out in front of the base to the exponent, okay? So got a common error here. Okay, so what do you do? Well, do your 4 to the 3x minus 2 equals 100. So log base 4 of 100 equals 3x minus 2. Now, some people are solving by taking the log of both sides, which is also completely valid, okay? I'm not going to do that because I want to keep it simple. But if you know the rules, you just apply log of this side equals log of this side, and it comes right out. I'll do at least one like that just to show everybody. But I'm not going to require you to be able to do that. But you're probably going to see it sometime in the future. As long as you understand the rules of logs, how to manipulate these things, you're going to be okay with that. All right. In any case, then, you get Three dots there, you do that intermediate step. At this point, you probably don't need to write +2 on both sides and do all those steps, okay? That's one you're probably not gonna make an error on. You might not need to do that much reinforcing on adding and subtracting for both sides. But if you get a wrong answer, check your answer that's wrong and check and make sure you did that right, okay? And other three dots. Okay, you get this. A log base 4 of 100 is about 2.0. This one is the curve 2.6. 1.6. Actually equals 1.5 maybe. Okay. If you plug it into your calculator. Again, check me on that. If this doesn't approximately equal that, you know, never to listen to me when it was approximation. Okay. Now something is wrong. Oh, I know. It should be 5.5, more like 1.8. 1.9. I just did a bonehead thing. I added like 2 to 2.6 and got 2, and I added 2.6 to 3.6. So I added 2 to 3.6 and got 4.6 to 5.6. It's just 1.8. I think maybe close to 1.9. All right. Did anybody happen to punch that one into the calculator? Okay. You probably would remember. All right. Just yeah, it's all right. Okay. So we got 3d to the 0.04t equals 15. Well, we divide both sides by 3. And then we change exponential form back to logarithmic form. Get log base b of 15/3 equals 0.04t. Now, log base e is your natural log. So you don't need to do log of 15/3 over log of b. You just do the natural log. Okay. So the b equals natural log of 15/3 over 0.04. And that you can punch into your calculator. Okay. Natural log of 15/3, that's about 5. So it would be about 40 something. Okay. Maybe. So it's 40 something, that would be 1.6. 1.6 power would be around 300. Yeah, that's probably right. Okay. Okay. Then you have this one, which is just some way all the rest of them are. Okay, if you divide both sides by 1,000, get 1.04 t equals 2. T equals step here. I don't think so. T equals log T over log of base 1.04. And it's going to come out something like maybe 18, give or take. Yeah. Notice that this is a double time. Okay. 1.04 for the T means whatever you've got is going to double every time T increases by 18. Every time T increases by about 18, this thing doubles. That's like you have $1,000 invested at 4%. An example, I'm sure we did something like last time or the time before. Okay. Can you tell me what the growth factor is for this function? 1,000 times 1.04. And now you have problems with that. And that's one of those things you should have a note. Okay. Let's take a little note here. I mean, growth rate and growth factor are important. They're in your text. You use the terminology. They're in the problems. You're asked to do it for a couple of problems. And it's really easy, so you forget what you did. Okay. That's really easy when your goal is just get the right answer and go on. Get the right answer, make a note of what you did. Okay. And on a separate piece of paper, don't embed that in your homework. You don't want to go back to your whole homework assignment and try to find the notes. If you've got a section of your notebook that's devoted to important notes, it's going to be very valuable to you. You can refresh your memory on important things that are easy to forget, like growth rate and growth factor. If your principal is 1,000 times 1.04 to the T, factor is 1.04. Growth rate is 0.0444%. This model a population maybe that grows at 4% per year, if T is in years. Okay. Or 4% per hour, if this is how many bacteria you've got in your food, and this is the number of hours you let it set out. Okay. Or the value of your account, if you started with $1,000, it grows at 4%, T's in years. Okay. Did I say that one already? Our population of 1,000 that grows at 4% each year. Okay. Those are standard models. You saw them in the first section of the chapter. You are familiar with words. You've learned something about taking the words and expressing them mathematically. Okay. And you got another assignment coming up. We get to do even more of that. We'll talk more about that Thursday because I think that was coming up this weekend. Okay. But you want to kind of focus on these things. And this is one of those things, a note on growth rate and growth factor. You really ought to have, and there are many other things. Okay. You know, if you have a propensity for quickly dividing both sides of this by 4, which is pretty natural since you usually divide by whatever's in front of your exponential part. Understand why that violates the order of operations, so you won't be likely to do it. If you do that, though, what do? You always check your work. Okay. You see me making estimates of this stuff, then in my head I'll plug the estimates back in there, and usually they seem to work. Now you can't estimate these things in your head. Most people can't. Okay. So I certainly don't expect anybody to do that, although if you can, I'd be impressed. I've been doing this for 100 years, and my brain hasn't died off completely, so I can still do it more or less. I make mistakes. Okay. Now you take your calculator or just do a rough calculation. Make sure your answer makes sense. Never give an answer that you haven't tested against making sense. And if you don't know how to test it against making sense, that means it's something you don't understand. And maybe in another section of your notebook or in the same section we do your notes, say, man, I got to review this. Okay. Let it settle in my brain for a couple of weeks and come back. Maybe it'll be okay. I was trying to study some fairly advanced quantum mechanics without writing anything down to see if I could keep my brain sharp enough to do it. Okay. I finally got to the point where I had to put it away for a couple of years. Okay. But the stuff I did is still more familiar to me than it was when I was looking at it a couple of years ago. Okay. Because I got it that deep into my brain. Now, pretty soon my brain's going to deteriorate enough to make sense. Can't find the door, but yeah, not to that point yet. Not nearly as quick as it used to be. Okay, so anyhow, the lesson on that is just get these things into your long-term memory using strategies, and long-term be like from now till the final. But then you're going to need it after that. And if you get it in long-term memory from now to the final, rather than memorizing a bunch of stuff that you more or less do right on the final, and don't forget, it'll be there when you need it later. Okay. That's enough advice for today. Let's solve some problems. Everything here, we've solved some equations already. In this next section, you're going to apply the rules for logarithms. Solve equations. Okay. Now, what are the rules for logarithms? I don't know. Have we talked about the rules for logarithms? I'm not sure we have, and I get confused between classes. Let's just see. Anything like that? Yeah, I'm not sure we've done it. I have done it in the support course because I try to keep the support course a little ahead of pre-calculus course, so that people who've been through the support course have a little bit of understanding. So when they go to pre-calculus class, they understand things much better. That's the whole model I use for the support course. Anyhow, so I've done that in the support course. Incidentally, another way to get that kind of stuff is read ahead. If you haven't read the text on the next assignment, at least briefly, you're not going to understand what I'm telling you as well. And you're not going to know who it is. And you won't learn as much being in class. Okay? So one way or another, try to get a little ahead of where we are. Don't come into class cold. Know what you did for your homework, how to do it, and read ahead so you know what I'm talking about when I'm talking about it. Okay? Now everybody in here is doing okay. Do a little better. Okay? So everybody can do a little better. Some people do extremely well. Some people get by just fine. Some people do even better than that. Okay? Okay, so I said I was going to stop giving advice and works and stuff, didn't I? Finish it up. talk about this. Okay. That's one of your rules. Okay. We'll practice in a minute. Apply. Here's another rule. A log of b equals log of b raised to the a power. Now I did something in the support course. Would be useful to see. No, I have already. Yeah. You got this hierarchy of operations. It's operations. It's estimate. Okay. Always try to prove that you're right. Okay. The hierarchy is exponentiation, then multiplication, division, then addition and subtraction. Everybody knows that's just order of operations. We're going to call it the hierarchy of operations. Okay. The top level is this. That's the first thing you do. Your bottom level is this. It's the last thing you do. And in the middle, you do this. Everybody knows the order of operations. Okay. Even if you violate it by dividing that 4. Okay. That's a natural thing to try to do. Okay. This level is, here are the rules again. Okay. Same rules I just wrote down. Okay. Notice, here we're going from addition to multiplication. Addition of 2 logs means we can take the log of the product of the things those logs were working on. Okay. In other words, we're going from an addition to multiplication. Okay. Rule 1 takes us from addition or subtraction up to multiplication or division. Okay. And rule 2 takes us from multiplication up to an exponentiation. Right? Do we see that? Okay. So you kind of want to make sure you understand that. All right. Now, your book is going to give you more rules than this. Another one is log 1 equals 0. And this applies whatever the base of your log is. If it's a log base 2 or log base e, which is a natural log, we can replace all these logs with ln's, natural log. Okay. And that's really, when I learned this, and you know, when I learned this in my junior, senior, or high school, so those are all the rules you need. Your book gives you a couple of others. Tells you that log of a minus log of b is a log of a divided by b. But since a divided by b is a times b to the -1, you just combine this with this and you get that law, and I thought it was superfluous. You'll see that law and go ahead and use it. I have no problem with that. Okay. But I start with these 3 because they're really 3. Everything else follows from these 3. And okay. So how would you apply one of these rules to this expression? Where do you see an expression that looks just like this up here? Well, it doesn't look just like this because we don't have a's and b's in this expression. We've got x and x plus 4s and stuff. But what rule has an expression that has the same form as this? If you see it, 1, 2, or 3, it's number 1. Okay. is 1, 2, 3. Okay. And that was your index number. Okay. So anyhow, it's fine. Just don't use that other finger on when you're driving. There's a level of rudeness that sets me. Okay, not that I'm all that comfortable anymore. Okay, so otherwise, okay, okay. So what do you get if you apply this rule to this? Write it down for me. You know, half the class wrote down log base 2 of x squared plus 4. I know how you got that. At least I hope that's how you got it. But write out the rule as literally as you can when you're first using it. Okay, so that you avoid a pitfall like that one. Well, this is log of A. Say I wrote it plus B. Just write B. I'll write it down. So that looks like a minus. Okay, you know what I'm writing out. It's this. Okay. And we can identify it. A is X, B is X times 4. It'll be X times X plus 4. This is what I saw. And I don't think you'd have gotten there if you hadn't been thinking this. But, you know, the distributive law, got to have a 4x there. Okay. So that's pretty good. Okay. Let's try a slightly more challenging one. Let's try to find some available books. Okay. Let's try this. And this over so you can see the rules here. Okay, now people were doing all kinds of things here that didn't work. Most people did something that didn't work at one step or another. And it involved the fact that there's a number in front of this log. If you look at the rule, there's no number in front of this log and there's no number in front of this log. If you've got a number in front of that log, what in the world are you going to do so that you can then apply this rule? Well, you got to get that number inside here somewhere. How do you do that? Well, you got the second rule, which you'll get used to after you've done a few problems. Okay. And maybe before you leave here. Okay. So this is the form A log B equals log B to the A. Okay. Which means that this term becomes log base 4 of B, which is the x minus 6. That's what you're taking the log of. Raised to the third power. Okay. Now you can apply the first rule. Everybody was doing the first rule right with whatever they were assuming. Okay, but they were assuming some stuff that wasn't right. And it's really easy to do this if you use both laws. And once you see it once, you probably have it. In case you don't, you're going to see videos in the open math assignment on some of the problems. And you make yourself some notes in that note place I told you to have. I'm not requiring that by any means, but recommending it. Okay. So this gives you then log base 4 of x plus 2 times x minus 6 cubed. Good idea to put parentheses around the whole cubing thing so you don't think you're cubing the log. Okay. And then you can expand. Inside the log if need be. You're going to get an x to the fourth and then a bunch of other stuff, right? You're going to get a negative 648. I have that, and then it got away from me. Okay. 6 cubed is 216. 2 times 16 isn't 648. That's 3 times 16. Okay. It's 422. Okay. It'll be negative. But anyhow, that's not important. But you would have an x cubed, and then you'd have this 6 cubed times 2, and then you'd have a bunch of other stuff in the middle, and you'd use a distributed law at every step to expand this, right? Okay, so expand if need be. Okay, well, let's try to solve the equation. Okay, there's a perfectly good equation. What can you do with that? See if you can apply the rules for logs to get this into a form that's closer to a solution. Okay, everybody did this quite well. You get log base 2 of x times x minus 3 equals 5. And you're trying to solve for x. What do you do next? You just solve some equations of this form. They didn't have necessarily an x times x plus 2 or something like that in it, okay? You just solve some for homework. How do you do this? Okay. So everybody's, I gave you the hand, you want to use this. So everybody has identified the A, B, and C. B, of course, is the base of your log. So B is 2, right? A is what's on the other side of the equal sign, which is 5. And the only thing that's left is what's inside of the parentheses after the log, which is x times x minus 3. Two to the fifth is 32. So you got x squared minus 3x equals 32. Now question, how do you solve that equation? Okay, so I read somebody's lips. I thought I saw quadratic blamed equation. That's a quadratic equation. What do you have to do? Put it in the form AB, x squared plus bx plus c equals 0. It has to be in that form before you can use a quadratic formula. And you want to have it in that form in case you can factor. So this becomes x squared minus 3x minus 32 equals 0. And there ain't no way you get a negative 3x. you get a negative 4x, that'd be x minus 8 times x plus 4. Sorry, x, yeah. Okay, but you're not going to get a 3x. So once you convince yourself you can't factor this, I just kind of scratched it down there. I think that's right. 137 is close to 144, so that's almost 12. So it's like 3 halves plus or minus 12 over 2, which would be 6. Okay. So not difficult to approximate. Okay. Be approximately 7.5 or 4.5. And if you plug that in, 7.5 could be 4.5 there times 4.5. Yeah, something will be wrong with that. Anyhow, that might be right. Notice that I always check. Okay. I estimate what I think the number ought to be. I did my calculation, I should have been close to what I said. Turns out it's not all that close. So maybe there's something wrong with what I did here. But it's pretty simple. So if I get it wrong, again, have a good chuckle. Well, there we have it. Okay, the whole thing in solving this thing is that we combine the two logs, we get this thing, and we change it to exponential or to exponential form. And that gives us a quadratic equation to solve. Now, if I had a 2 in front of this log base 2, okay, then you would have had an x minus 3 squared inside the log. And you have x times x minus 3 squared, which gives you a cubic equation. Okay, so you could still solve it. So you got to maintain those skills. Okay, that's pretty much what you need to know. And really, this stuff is really pretty simple if you practice it. Much easier than learning to graph a rational function or figure out what the rational function is for this graph. I told you things are going to get easy. Okay. And this stuff is actually a whole lot more important than rational functions, even polynomials for most people. Still, that other stuff is stuff you want to know, as it could come up, especially if you're going to take a calculus course. You're going to need to know the basics. So what I want you to do now is I want you to just make yourself a couple of notes. Okay, put another sheet of paper. Yeah, just turn a page in the notebook and do your notebook. But actually hand it in. But I want to look at it and then just give some general advice on what I see. Okay, we'll start maybe trying to develop the art of making a note that'll be useful to you when you are studying for the exam, so you won't have to spend as much time preparing, and so you'll even do better on the exam with less time. That's the goal. Learn this stuff as effectively as possible to retain it. Okay. So don't write down any equations or anything. You've already got those. You've already got examples. Okay. That doesn't mean you can't include examples when you do that. You think it's going to be a good illustrative example, just remind yourself. Okay. But don't be using these examples. Don't make up examples now. You don't have time. Okay. You just write some words that you think would be useful to you a month from now when you're tearing your hair out over all the exams and everything at the end of the semester. Okay? To make your life a little bit easier at that point. Okay, now what I'm saying, certainly good to write down the rules. Okay? Maybe not necessary, but good. And maybe what you have is maybe you decide to break it into sections where you got the expressions for the rules and another section where you explain to yourself how to use them. Okay? Or maybe they're all together. That, you know, everybody's got their own style that they can develop. Okay? So there are many ways you can do this. But you know, a lot of times people didn't get a whole lot further just writing down the rules. But then I said, a couple of blurbs, I said, you will have to, I didn't get to read the rest because somebody was still writing, okay? Or here you need to do this, okay? Or another type of expression, okay? Some narrative explanation to yourself that will jog your memory along with the expression of the rules, which is certainly an appropriate thing to have. Does that make sense? And I'm going to also recommend, and I'm not insisting on it, but or I'm offering, if you include this in the scan that you send me, I can make some comments on it. Like if you got something that's in error there, I can say, hey, you know, you might want to rethink that. Okay, here's how I might put it, but you figure out how you need it. Okay, or I might say that was a really good way to say it. Okay, I'll give you a little constructive critique of what you've written and maybe a hint. You know, you can make it even better if you did a little of this. Try to answer this question or that type of question. Okay, I'm glad to coach you in that way, and as well as in class because it's a small class. Unfortunately, showed up with way more people than we have now. Okay, so again, I don't require it. There's no penalty if you don't. But if you do, I think it might benefit. Just based on the patterns I see on tests, and especially on tests from some other classes that I teach, especially some developmental classes. And I think I'm going to maybe include this advice to my engineering students who take in calculus-based physics. Okay, because I think they could really benefit from it. So let's see if it works. Let's see if you find it helpful. Okay, good luck with it. But I don't think you'll have much trouble with the assignment.